Welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Joe McChesney.
Good morning. Thank you for joining us today. Today's topic is vacuum vapor degreasing. You get a lot of calls about people that ask, what is vacuum vapor degreasing? It's basically a process of applying solvent to a variety of parts inside a sealed chamber under a vacuum. If you look at the left, you'll see a typical work chamber where you see the solvent being applied to the product. On the right is a typical vacuum degreaser in a production world, multiple baskets going through multiple type of parts. And there's a lot more to tell about vacuum vapor degreasing, lots more. It's the fastest growing technology in the world today. If you look at the slide, you'll see that you can have a pre-wash process, no air inside the machine, totally sealed. It goes into immersion. You can have spray under immersion. You can have ultrasonics. You can have multiple rinses and sprays. Again, nothing exposed to the atmosphere, only the parts and solvent. No solvent drag out when the parts exit the machine. And why is this the technology trend? Because people are moving to environmentally clean greening processes for complex and challenging parts. If it's easy to clean, there's probably an easier way to do it. But if you're moving away from the legacy halogenated solvents such as PERC, TCE, methylene chloride, and NPB due to the EH&S issues, a lot of people are also moving away from water-based processes due to consumption, discharge, energy, residues, and cost of operations. And they're moving toward vacuum vapor degreasing. There are many advantages to implementing a vacuum vapor degreaser. First is environmental safety. No operators exposed, the ambient area is not exposed, the parts are totally sealed up inside a machine as the chemistry is being applied. The operational efficiency, it's under a vacuum. You can provide multiple processes for different types of parts. You can have rotation, oscillation, you can have spray, high pressure spray, you can have immersion with or without sonics, multiple stages, accessory options, etc. And this gives you the flexibility to pick and choose what you want to process your parts in your facility. You can future-proof your solvent process sustainability with vacuum vapor degreasing. It's not under any environmental actions. It basically is a safe solvent because it's contained inside the machines, and it has great cleaning performance. The flexibility effectively cleans challenging parts made in oil and water in the same machine. You can have parts in your facility that's being processed with oil or lubes, or you can have water-soluble coolants and remove them all in the same machine without having different machines based on your recipes that you select. So how does it work? Well, the work is loaded into the process chamber and the door is closed and locked. The work inside the chamber is isolated from the ambient atmosphere, just as much as the operator is. The vacuum vapor degreaser extracts all the air out of the system. And why is this important? It makes the ultrasonics more efficient. There's nothing there basically but the solvent being applied to the parts. The hot solvent is applied to the work in various stages, a pre-wash, a wash, a rinse. No operators are exposed to the process while this work is going on. And by using a sealed chamber, the parts are evacuated, but no solvent is lost during processing. So the core feature of the system is the work chamber. You basically have a variety of options that you can set up through your recipes. The work is totally enclosed. You can either rotate the work or you can oscillate it if the parts are sensitive to the surface finish. You basically can have spray under immersion. You can have ultrasonics. You can have flooding sprays from the top. And when the process is over, the work exits completely dry. There's no drag out of solvent inside or outside on the parts. You can take your hand and run down into a basket of parts in the middle of the parts, and you will find no solvent residue inside there. They also feature continuous solvent distillation, as the solvent is basically becoming contaminated because it's removing the solvent, and on progressive stages, the solvent is distilled. You see it on the right as a typical vacuum vapor degreaser distillation system. It boils the solvent, the hot vapors come up, they condense, they go through a water separator, take out any moisture. They go to the final rinse tank, which overflows to the middle rinse tank, and then finally back to the first rinse tank. So you have progressive stages of cleaner grade solvents your parts are being exposed to during real life applications. And sometimes solvent is simply a better choice. If you look at the part, and I'm holding in my hand on the left side, that has very small ID diameter holes. If you look at the one on the top with the dime, that is a blind hole down inside. And if you look at the canisters, these basically come out totally clean and dry with no residue inside those canisters for food grade products. If you look at the challenging parts in bulk processing, this is where vacuum degreasing really shines. It basically will clean parts in bulk loading and complex geometry. It'll clean, rinse, and dry all in one machine. And if you look at the slide on the right, you'll see the clean and dry parts. This is the actual photo, and it only took 10 to 12 minutes to clean these brass parts, de-chipped them, took all the fines off, because once the oil is gone, there's nothing there to hold the fines to it. And the immersion solvent with the sonics removes the fines from the system that go down into your filter. Where it's complex geometry, drying and drag out is the challenge. And if you look at what is a complex geometry, look in the middle slide there where my hand, you'll see chips, fines, and small orifices. You'll see surface finishing on the right-hand side. It's very critical that nothing be damaged, but you've got holes, blind holes, tapped holes, cavities, etc. in the parts, and all those must be cleaned. Solvent will go where water will never go, and you can evaporate it back out through the vacuum and remove it very quickly. So, what are the benefits of vacuum vapor degreasing? Well, first, there's no processed water. You have nothing to basically provide or treat going out under the Clean Water Act. It's reduced floor space. These are very compact machines, typically 6x6 or 8x8, and everything occurs inside one machine. There are much larger machines. Some of them, such as baskets, like 10-foot long but 6 feet wide but 4 feet high. These are for large aerospace parts. There's no chemical mixing. It is a neat chemistry that's applied inside the machine and reused over and over and over again due to the distillation system. Again, there's no operator exposure, neither to the operator itself or to the ambient area where the machine is located in. The single process chemistry goes in, neat, 100%, is being distilled, so very little consumption. And the waste that's removed, there's only typically 1 to 2% of the solvent in the waste stream that's going out. Reduced energy, because it's under a vacuum, it takes less heat to generate the vapors and heat the solvent up. Everything's sealed up, so it's very energy efficient. And reduced waste disposal. There's nothing going to drain. There's no water. There's no solvent being taken out of the machine. There is a waste stream that goes out as your soils that's been removed, as I previously stated. Low solvent consumption. These machines use very little solvent during normal operations. And if you look at the total cost of operation, this is the lowest cost either per piece or per hour in the industry today for solvent cleaning. So you can future-proof your solvent cleaning by looking at vacuum vapor degreasing. It is a clean and green process. It offers better cleaning because the low surface tension allows it to penetrate and evaporate back out, carrying all the soils out and leaving a residue-free surface. It's continuous removal of contaminants from the solvent, so you have multiple stages of progressive cleaning, and it works on polar and non-polar soils. It's green. There's zero emissions under vacuum operation. Parts come out dry, no drag out. Lower operating cost, less energy, less solvent consumption, waste consolidation, and there's no water consumption. And it's safe. It reduces the human exposure. It's not regulated as a HAP by the EPA, and it has global approval. So, in summary, why vacuum degreasing? It's an excellent cleaning choice for a wide range of soils. The ability to clean and dry parts without separating is huge. It cleans and dries complex geometry, from engine blocks to heads to medical devices, aerospace devices. It excels in complex geometry. Continuous removal of contaminants from the cleaning solvent via the distillation system inside the machines. This is a huge plus. Parts are constantly being exposed to cleaner solvent on a continuous basis. Operator isolation from the process is another safety plus. It meets all the environmental codes from the EPA and OSHA. And there's no water used. This is a big plus. You simply can hook it up, apply the electricity and some compressed air, and that's all you need to do. So it is the sustainable cleaning process for the future in solvent cleaning. I put together a list of typical questions that I receive on a continuous basis and can use the same solvent in vacuum degreasing and traditional degreasers. And the answer is no. The vacuum degreasing solvents boil at a higher boiling point, and they have a different chemical makeup, so therefore they're not available to be used in traditional degreasers. They differ in the chemical type that's in there, and because of the higher boiling point, you need to pull a vacuum to lower the temperature down, the vacuum pressure down in order to boil the solvent and generate vapors. When is vacuum degreasing a better choice over traditional vapor degreasing processes? When you have process that requires removing both polar and nonpolar soils, you have complex geometry, you have bulk loading where you need excellent drying, the vacuum degreasers offer a better choice. Traditional vapor degreasers still have emissive losses when the cover is opened and they're in operation. You don't get a lot of the multiple recipes that you can get in a vacuum degreaser, such as your sonics, such as rotation, oscillation, flooding sprays, or high pressure sprays. Some of that may be available in vapor degreasers, but you pay extra for those options. So, what is the best method to ensure that vacuum degreasing solvents will meet my cleaning requirements? Again, test, test, test. Have your parts and your soils sent to a professional company that can verify that they basically will meet the cleaning specifications and requirements, meet your throughput specifications and requirements, and basically meet the environmental specifications and requirements. And most companies will do this for free. I know KYZEN does this, so feel free to ask us if you need help. And the final question that I listed, are modified alcohols or hydrocarbon solvents subject to current environmental regulatory action? They are not. They are different solvents than the traditional vapor degreasing solvents. These solvents have been reviewed by the EPA and OSHA, and they carry current guidelines that specify they're not subject to environmental regulatory actions. We feel that these are the future of solvent degreasing. And at this point, because of the higher part per million for the modified alcohol or the fact that they do not contain PFAS substances, they do not contain HFEs or HFCs, make these viable for the long-term future. And with that, I thank you for our time today and appreciate you listening to KYZEN Tech to Tech.
Thanks, Joe. Thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.